Hello everybody, I'm Dr. Peter Bleakley, a freelance data scientist with an R&D background and a particular interest in natural language processing. If you'd like to find out more about me and my work, or potentially work with me, please take a look at my company website, which is linked in the description. Now, there's an old saying that I heard in a Terry Pratchett book, that a lie can run around the world before the truth has got its boots on. And this seems to be particularly true on the internet and social media. There was a study published a couple of years ago saying that fake news spreads 6 times faster than real news on Twitter. So, obviously, I started wondering, what can data scientists do about this? And I wasn't the only one thinking that, because Megan Ridsdale of Kaggle posted a fake news dataset, about 13,000 articles from sites that had been flagged as unreliable by the BS Detector Chrome extension. Now, at the heart of that, there's a hand-curated list of dodgy sites, so that looked to be a good source of fake news. Now, to distinguish between fake news and real news, we obviously needed a corpus of real news. So I used the Reuters Newswire corpus, which is available from NLTK, and that's about 10,000 articles. So it's a fairly balanced data set. Not perfectly, but not too far out either. Now, the first decision I made was about the most counterintuitive decision that you can make in an NLP project, which was not to use the vocabulary. And the reason for that, well, there were 3 reasons. The first is that the corpora are from very different time periods. The fake news data set is from around 2016. The Reuters dataset is from around 1987. So if you'd used the vocabulary, that would have introduced a lot of bias. It would have thought anything mentioning Hillary Clinton was fake news and anything mentioning Ronald Reagan was true, for example. And that brings us on to the second problem, in that it would be very difficult to generalise. The third problem that I foresaw with this was that somebody who was trying to produce fake news could work out what sorts of keywords and phrases the fake news detector thought were true, insert those into fake news articles, and easily fool it. So what did I do instead? Well, as you saw from the title, The Grammar of Truth and Lies, I decided to use the structure of the sentences as my features. So what I did, I used a TextBlob library to perform part of speech tagging, and then I concatenated the tags to form a feature for each sentence. So there, a little thing I've written about myself, and there's the feature we generate from it, and of course that produced a very large, very sparse feature set. Just how large and how sparse is something that will be important later on, so we'll come back to that. And then obviously you need to do some data reduction on that, so we trained a latent semantic indexing model, that came from Gensim obviously, on the sentence structure features, and brought that down to 200, a 200 dimensional vector. Then using the usual 70-30 split on training into test data, the next thing I did was I trained a logistic regression model, which came from scikit-learn. So let's see what happened. Here's the Kaggle kernel. Again, we'll zoom in a bit. And so here is the code that extracts the features and acts as our corpus. Here's the here we are training the latent semantic indexing model, and then we train our classifier, and let's plot out the heat map. So here we have the true positives, things correctly identified as true, the false negatives, true articles that were labelled as fake news, the true negatives, the fake news that was correctly identified, and the false positives, the fake news articles that slipped through the net. So, what does that come out in as some metrics? We have got precision of 61%, recall 96%, we saw that there were hardly any false negatives, overall accuracy is 70%, and the Matthews correlation coefficient, which is a measure of how much better we're doing than guesswork, so factoring out the imbalance between the data sets, is 50%. So 50% better than guesswork is not bad for a start. And the recall looks impressive, but it's really the precision that measures our ability to catch the bad guys. We are only, about 40% of the stuff we've got labelled as true is actually fake news. So, we can do a bit better than that, hopefully. So the next thing I tried to use was sentiment analysis. Now, the thing is, fake news, one of the reasons it spreads so quickly is that it's written to provoke a reaction, and also to tell you what you think you want to know. And so used the fader model that's in an LTK, and that produced positive, negative and neutral scores for each sentence. We took the sum of those over the document, and let's see what happened when we did that. And here we have the confusion matrix for using the sentiment analysis, and we're seeing a few more false negatives, but not as many false positives. So there's an improvement. We've got the precision's up to 71%, the recall is 88%, accuracy is now 79%, and the Matthews, and we're now doing 59% better than guesswork. So let's see what happens when we combine those two things, the sentence structures and the sentiment analysis. And yes, there we are. In fact, we're seeing very similar performance to sentiment analysis alone here. So, yeah, it's a slight improvement, but it does look that like this particular classifier is just using the sentiment analysis and more or less ignoring the grammar here. The next thing I did was, instead of the latent semantic logistic regression, I tried random forests as the classifier. What we're seeing here, we're getting 83% precision, 89% recall, 86% accuracy, and 71% Matthews coefficient for sentence structure. Interestingly, it doesn't do as well using just sentiment analysis, and it gets a slight improvement, but not very significant, over sentence structure when we use both. But here, the sentence structure seems to be doing most of the work. Now, at this point, there are two roads you can go by, but in the long run, there's still time to change the route you're on. You could either try throwing more maths at the problem, or you could take a closer look at the data and see what's really going on, which is, of course, what you should do. Never throw maths at a problem before you really understand the data. So, trying to understand the models. We had 333,666 unique sentence structure features, but 2/3 of those only occur in, well, no, it's more than 2/3. Most of them only occur in a single document. And out of our sample of 23,000 documents, 11,000 have no features in common with any others. So you see that when we use logistic regression, that is trying to find the best possible combination of all the features that it can get the classifier out of, and whereas with the, and so that found that, and so that kind of latched on to the sentiment analysis as the most useful features, whereas the random forests tried to find a lot of any combination of features that it could get some sort of classifier with and then vote on them together, and then that was getting more use out of the sentence structure features and wasn't, and actually didn't really need to use the sentiment analysis much at all. And we can also see why we had better recall than precision. So there were just some features that always occurred in true articles, but there weren't really any sentence structure features that only occurred in false articles. Now, we need some denser features, and we would like them to have the same kind of features, the same kind of properties that motivated us to choose the sentence structure features in the first place. Independent of content, but possibly able to work as poker player tells to give us a sign of when something's amiss. So I looked at function words, things like pronouns, prepositions, conjunctions, auxiliaries. Now, they're the most common words in the language, so they're going to be everywhere. So that solves our sparsity problem. Now, usually in natural language processing, you discard these as stop words, but they have their uses: stylometric analysis, document attribution, and the NLT stop words corpus to help us pick them out. So, now we didn't throw away the original sentence structure features because they clearly had some use, so we trained a new model. Now that's a random forest classifier. Skip down a bit more. Yeah, here we are exploring the feature space, and here's our stop words, and so here we come to sentence structure features. This is wrapped a bit because I expanded the screen, but here is our confusion matrix, and we are seeing low numbers of both false negatives and false positives. So what do our metrics say here? 90% precision, 96% recall, 93% accuracy, and a Matthews coefficient of 87%. That, I think, looks quite impressive, but there are caveats. We have learnt that grammatical and stylistic features can be used to distinguish between real and fake news to quite a good degree of accuracy, at least on this data set, and that a good choice of features is the keys to success on this particular problem, rather than a particularly clever algorithm. There is, however, the question of, will this generalise to other sources? We used one source of real news and one source of fake news. In the wild, you wouldn't want to rely on a single approach. There are many other people working on fake news detection, many other approaches, and I think this is potentially one part of a bigger toolkit that could be useful for finding and detecting fake news. But as I say, while it looks good like this, you would have to use it in conjunction with other things. Now, I hope you found that interesting. Before I go, I'd like to remind you again about my forthcoming Ask a Data Scientist webinar series. You'll be able to send me questions, and I'll go through live coding examples like this to talk through the answers. There'll be a fee to take part in the live session, but the videos will be available on this channel afterwards. So please follow the links in the description, subscribe to the channel, share the video, and you can contact me via my email address, peterbleakley@playfultechnology.co.uk, or via the comments section. And the next episode will be about part of speech tagging.